What precisely lies at the edge of the indisputable universe? Without question, this has stayed private for a surprisingly long time, controlling interest and standard among researchers and fans. The James Webb Space Telescope holds the best way to deal with uncovering this colossal secret. With its strong focal core interests looking further into space, it has indeed offered an important expression of what lies at the edge of the noticeable universe. Exactly when we analyze the edge of the universe, getting the chance of the noticeable universe is fundamental. The noticeable universe consolidates everything that could be seen, measured, and studied from Earth or our space-based telescopes and exploratory tests. Right now, it contains stars, frameworks, and other splendid articles that are within our observational reach. Consequently, what's the capability between the universe, with a capital U, and the recognizable universe? In direct terms, the recognizable universe is only a bit of the whole universe that we can study and appreciate. While the total size and state of the whole universe are unknown, there is a typical width of the undeniable universe, which is around 93 billion light-years. A light-year is a unit of distance that light goes in 1 year, which is around 5.88 trillion miles, or 9.46 trillion kilometers. Appropriately, the width of the noticeable universe, 93 billion light-years, is an inconceivably huge field spreading over around 546 billion miles. The response lies in its starting stages. The hypothesis of how things came to be lets us know that for the most part, 13.8 billion years back, the universe was brought into the world in a solid effect. This interesting occasion set off a quick turn of events. From there on out, the universe has been expanding at an incredibly fast speed driven by peculiar forces like dark energy. As the universe extended, particles of matter began assembling due to the power of gravity, shaping astounding plans like stars, frameworks, and eventually even planets like our adored Earth. Over endless years, these huge plans expanded and turned out to be more complicated, prompting the phenomenal grouping of things and phenomena that we observe throughout the universe today. Notwithstanding the vastness of the universe, it is overwhelmingly void. To place in context, on the off chance that we cut back our whole nearby planetary group to the size of a quarter, the closest star would still be the distance of 2 soccer fields away. This is inside our Milky Way galaxy, which is one among billions in the noticeable universe. You might consider why we could never see the whole universe. There are 2 components that explain this. The first reason is that light requires some time to travel through space. At the moment that we look at far-off objects in the universe, we're genuinely seeing them as they were in the past. The farther away an object is, the more time its light has taken to reach us. Along these lines, by seeing far-off structures, we're basically looking back in time, unraveling the true history of our universe. The second explanation is the universe's expansion. Imagine spots on the outer layer of an expanding balloon. As the balloon grows, the spots move away from one another. A similar principle applies to the universe, where structures are floating apart as space itself expands. This expansion makes the light from distant objects become stretched out, moving towards longer wavelengths, which we see as redshift. Eventually, some objects will move beyond our observational reach as they retreat past a certain distance. Considering these factors, it's not surprising that we haven't seen the whole universe yet. However, the prospect of the edge of the universe is a fascinating subject that has captivated experts, academics, and minds seemingly forever. We have a broad assortment of theories about what lies beyond, yet reality remains intriguing. There are 3 main hypotheses that stand out. The first hypothesis is that the universe continues forever. This hypothesis depends upon the cosmological principle, which conveys that the universe is isotropic, implying that it appears the same in every direction. Assuming this principle holds true, it suggests that the universe extends infinitely without an end. The second hypothesis proposes the universe is finite, but doesn't have a clear edge. Instead, it suggests it's similar to a giant ball, and if you travel in any direction, you will eventually return to where you started. The third hypothesis is the multiverse theory, which proposes that our universe is just one of many imagined universes, each with its own set of rules and properties. These universes could be completely different from one another or somehow related. Thus, we've explored theories about the edge of the universe. By looking at these hypotheses, we turn our attention to a remarkable tool that holds the potential to reveal information about these mysteries: the James Webb Space Telescope, JWST. This immense telescope allows us to look far back in time and discover extraordinary objects from the beginning of the universe. The JWST, with its advanced capabilities, has empowered cosmologists to peer into the early universe. And prepare to be amazed, they've accidentally found something unexpected. In a new report published in the journal Nature, the JWST tracked down 6 colossal galaxies that existed between 500 million and 700 million years after the Big Bang. Scientists were expecting to find small, newly formed structures. Instead, the JWST captured images of much larger and more complex structures than anyone could have anticipated, challenging what we thought we knew about the early universe. But that's not all. Researchers also discovered that these galaxies are as mature as our 13-billion-year-old Milky Way. The massive stars within these galaxies amount to several times more than that of our Sun. According to the evaluation, one of them could be as much as 100 billion times our Sun's mass. For comparison, the Milky Way contains a mass of stars equivalent to around 60 billion suns. This telescope has an unprecedented power. It can see things that are invisible to our eyes by utilizing infrared light, capturing the faint glow from old stars and vast structures that have existed for seemingly forever. The JWST can effectively take us back in time, providing a glimpse of what the universe looked like around 13 billion years ago. Here's where it gets truly fascinating. The universe is estimated to be around 13.7 billion years old, so this discovery has turned things upside down, almost like rewriting the history books. These colossal galaxies, nicknamed universe breakers, have experts scratching their heads, challenging most of the models we had for early galaxies. We used to think galaxies started as small clusters of stars and slowly developed over time. These universe breakers prove that wrong. When the Webb data and high-resolution photographs from the telescope were released in July 2022, specialists were stunned. They were astonished when they saw these galaxies as massive sources of light, altering their interpretation of the data. The unexpected appearance of these enormous structures left everyone in awe. By using spectroscopic techniques to analyze light across different wavelengths, researchers can uncover crucial information about these galaxies, such as their structure, size, and distance from Earth. It's captivating that this significant discovery wasn't even on the initial list of things experts expected to find with the James Webb Space Telescope. The JWST exceeded all expectations and did so much faster than anticipated. There's even a possibility that some of the objects found using Webb data might be something completely unique. While most are likely galaxies, a few could be exceptionally massive black holes. Here's the fascinating part. The known mass of stars in the universe is now recognized to be significantly more than previously thought. This revelation is still surprising even when considering just a portion of the model. The new discovery focuses on 4 galaxies with redshifts greater than 10, meaning they are really far away. The Hubble Space Telescope recently spotted 2 of these galaxies, and their redshifts were confirmed to be 10.38 and 11.58. Additionally, the JWST's Advanced Deep Field Survey (JADES), JWST Advanced Deep Extragalactic Survey, is an extensive program that has been allocated over a month of the telescope's time. Its goal is to provide an in-depth study of the early universe. In 2015, a consortium of instrument teams proposed this project, forming a global collaboration known as JADES. It included over 80 cosmologists and experts from 10 different countries. Starting with NIRCam, the JADES program dedicated over 10 days of mission time to observing a section of the sky, including the Hubble Ultra Deep Field. For years, cosmologists have been studying this region using various large telescopes. By focusing on the field in 9 different infrared wavelength bands, the JADES team made an outstanding observation of nearly 100,000 distant structures, each billions of light-years away. Then, using the NIRSpec spectrograph, researchers collected light from 250 faint galaxies during a 3-day observation period. This allowed them to uncover the properties of the gas and stars within these galaxies and obtain precise redshift values. With these evaluations, astronomers can determine the intrinsic brightness of the galaxies and measure how many stars they contain, allowing for a comprehensive assessment of galaxy formation over time. Even without direct information on their early stages, studying these structures can be as challenging as understanding people. The early stages of star formation significantly influence the fate of galaxies, just as our early experiences shape our lives. This is a remarkable time in history when the extraordinary capabilities of the Webb telescope are answering numerous questions about cosmic systems. NASA's Significant Space Observatory, the JWST, is continuously transforming our understanding of the universe.